So in this video, we are going to learn how to evaluate definite integrals by U-substitution. Now with U-substitution, what you are basically going to do is to substitute U in place of X into the integral, which means that we are also going to make changes to the original limits of the integral. Now the reason why I would like to use U-substitution is simply because it reduces the size or the complexity of the integral. So let's take our very first example. So we are going to integrate this function, that is 3x times e to the power 2x squared minus 1 dx, that is from 0 to 1. Let's try to solve this question together. So first of all, you need to realize that because we are using U-substitution, we need to represent some expression in this integral by u. So first, let's say let u be equal to the exponent on e, so that is 2x squared minus 1. Now the next thing we are going to do is to find the x. In finding the x, we first of all need to find du dx, that is trying to find the derivative of this function with respect to x. So when you differentiate 2x squared with respect to x, then you have 4x, derivative of a constant is 0. Next, let's make the x the subject. So we have the x to be equal to, basically we are just going to interchange the positions of 4x and then the x. So you have the x equals du divided by 4x. So we have the x to be equal to du divided by 4x, and then we have this to be u. Now at this point, we are going to substitute u and then the x into this integral. So we have the integral of x equals 0 to x equals 1. That is the limits of the original integral, and then we have the function to be 3 times x times e to the power 2x squared minus 1 dx, and that is equal to, so let's substitute u and then dx into this integral. So we have x equals 0 and then x equals 1 of 3 times x times e to the power u times, now we have the x to be du divided by 4x. Now let's proceed. So x cancels out x, and then we have 3 divided by 4, that is a constant, so we can pull that one out. So we have 3 divided by 4, and then we have the integral of x equals 0, x equals 1 of e to the power u du. Now at this point, you still realize that we have values of x in this integral, which are the lower and the upper limits. So now let's work on the limits as we try to change the values of x to the values of u. Now we know that u is equal to 2x squared minus 1. So we say that for u to be equal to 2x squared minus 1, when x is equal to 1, that is when considering the upper limit, we have u equals 2 times 1 squared minus 1. Now 2 times 1 squared is 2, minus 1 is 1. And then when x is equal to 0, for the lower limit, we have u equals 2 times 0 squared minus 1. Now 2 times 0 squared is 0, minus 1 is negative 1. So we have the upper limit changing from x equals 1 to u equals 1, and then lower limit x equals 0 changes to u equals negative 1. Now let's plug in 1 and then negative 1 into this integral. So we are going to have 3 over 4 times the integral of, we have u equals 1, that is for the upper limit, and then u equals -1 for the lower limit, e to the power u du. So at this point, we've been able to successfully remove all components of x in this integral, and we are left with the integral of e to the power u. Now let's integrate e to the power u. So we still have the constant 3 over 4 on the outside. Now when you integrate e to the power u, you still have e to the power u, and then we are going to apply the limits to that. So we have the lower limit to be -1, upper limit 1. We are going to substitute 1 and then -1 in place of u. Now plugging those two values in here, we have 3 over 4 times e to the power 1 minus e to the power -1. Now let's further simplify this. So we have 3 over 4 times e to the power 1 is still e, minus e to the power -1 is 1 over e. So the LCM between 1 and e is e. So e divided by 1 is e, e times e is e square, minus e divided by e is 1, 1 times 1 is 1. So finally, we have our result to be 3 over 4 times e square minus 1, all divided by e. So to example 2, we are going to evaluate the integral of 2x over 4 plus 3x square all square with respect to x, and we have the lower limit to be 1, upper limit to be 3. So how do we solve this question? Now whenever you have a rational function, the best way to handle it is to focus on the denominator. So with this, we say that let u be the expression we have in the brackets at the denominator. So that is basically 4 plus 3x squared. In that case, we have du dx to be equal to derivative of the constant becomes 0, and then 3x squared becomes 6x. Next, we can find an expression for dx. So that's going to be du divided by 6x. Now let's plug in the value of u, or the expression for u, and then dx into this integral. So we are going to have the integral of 2x divided by 4 plus 3x squared all square dx from 1 to 3, and that will be equal to, we have the integral of the function. So we are going to have 2x divided by, now 4 plus 3x squared is u, so we have u squared times dx is du divided by 6x, and then we still have the limits 1 to 3. Now 2 goes here once, 2 goes here 3 times, x cancels out x, and so we have 1 over 3 as the constant, so that one comes outside. We have the limits 1 to 3, and then we are left with 1 over u squared. Now 1 over u squared can also be thought of as u to the power -2, and then times du. Now don't forget that these limits are the original limits for this integral, and hence are the x values. So we have the upper limit to be x equals 3, lower limit x equals 1. Now let's change these x values to u values. So we say that for u equals 4 plus 3x squared. When x is equal to the upper limit 3, we have u to be equal to 4 plus, now 3 squared is 9, 9 times 3 is 27. So 4 plus 27 is 31. And then when x is equal to the lower limit 1, u is equal to 4 plus 1 squared is 1 times 3 is 3. 4 plus 3 is 7. So we have upper limit to be 31, lower limit to be 7. Now let's plug in these values in place of 3 and then 1 respectively. So we have that to be equal to 1 over 3 on the outside. We have integral from 7 to 31 of u to the power negative 2 du. Now we are going to integrate u to the power negative 2 with respect to u. So we are going to have 1 over 3, and then we integrate u to the power negative 2, so that becomes u to the power. So basically we are going to increase the exponent by 1, and then we divide by the total exponent on u, so that is negative 2 plus 1. We have the upper limit 31, lower limit 7. So 1 over 3 into brackets, negative 2 plus 1 is negative 1. So u to the power negative 1 divided by negative 1, 7, 31. Now we can multiply negative 1 by 1 over 3. So we have negative 1 over 3 on the outside. And then we plug in the values of the upper and the lower limits. So we have u to the power negative 1 is the same as 1 over u. So we are going to have 1 over 31 minus 1 over 7. Now the LCM between 31 and 7 is 217. So we have negative 1 over 3, and then the LCM is 217. 217 divided by 31 is 7. 7 times 1 is 7. Minus 217 divided by 7 is 31. Times 1 is still 31. So we have negative 1 over 3 times 7 minus 31 is negative 24. So 3 goes here once, 3 goes here 8 times. We have negative 1 times negative 8. That becomes 8. So we have our final answer to be 8 divided by 217. Now let's move on to our third example. Now to example 3. We are going to evaluate the integral of 1 plus 2 cos x all cube times sine x with respect to x, and then we have the lower limit to be 0, upper limit to be pi on 2. Now, whenever you have a complex expression like this, especially the product of two functions, it is more appropriate to let u be equal to the expression which seems more complex. Now, looking at these two products, you realize that 1 plus 2 cos x is more complex as compared to sine x. So we say that we are going to let u be equal to 1 plus 2 cos x. Therefore, we have du dx to be equal to, this is a constant, it goes to 0, and then when you differentiate cos x, you have negative sine x. So this becomes negative 2 sine x. And then for that matter, we have the x to be equal to du divided by negative 2 sine x. So let's plug in the x and then u into this integral. So we have the integral of 1 plus 2 cos x cube times sine x dx from 0 to pi on 2 to be equal to 1 plus 2 cos x is u, so u cube times sine x times dx is du divided by negative 2 sine x. So sine x cancels out sine x, and then we are left with 1 over negative 2. So that comes outside. So negative 1 over 2 comes outside. We have the integral of u cube du from 0 to pi on 2. So these are values of x. That is, the limits we have are values of x. So let's change them to values of u. So for u equals 1 plus 2 cos x, when x is equal to pi on 2, u is equal to, so 1 plus 2 cos pi on 2. Now, cos pi on 2 is the same as cos 90, which is 0. 2 times 0 is 0, so 1 plus 0 is 1. And then, when x is equal to 0, u is equal to 1 plus 2 cos 0. Now, cos 0 is 1, so 2 times 1 is 2, plus 1, that is 3. So we are going to get negative 1 over 2 times the integral of u cube du from 3 to 1. Now let's further simplify this. So at this point, you are going to perform integration on u cube. So when you integrate u cube, you are going to get u to the power 4. You increase the exponent by 1, and then you have divided by the value of the exponent on u. You have the lower limit to be 3, upper limit to be 1. So next, we are going to do substitution of limits. So we have negative 1 over 2 times 1 to the power 4 divided by 4 minus 3 to the power 4 divided by 4. So this is equal to negative 1 over 2 times 1 to the power 4 is 1. So we have 1 over 4 minus 3 to the power 4 is 81. So 81 divided by 4. Now because we have the same denominator, we simply subtract the numerator. So 1 minus 81 is negative 80. So negative 80 over 4. Now let's multiply across. So negative times negative become positive. 1 times 80 is 80. 2 times 4 is 8. And then 80 divided by 8 is 10. Therefore, we have our final answer to be equal to 10. Now let's take the last example for today's lesson. So let's try to find the integral of the function. We have the integral of 1 over x times ln of x dx from e to 3. So as usual, focusing on the denominator, let us make u be equal to ln of x. Let's make u to be equal to ln of x. Therefore, we have du dx to be equal to 1 over x, and thus the x is simply equal to, so we have the x times 1. When we cross multiply, we have the x times 1, which is still dx, and then x times du, which is x du. So we plug in u and then the x into this integral. So we have the integral of 1 over x times ln of x dx from e to 3. That will be equal to the integral from e to 3 of 1 over x times u times, we have the x, which is x times du. So x cancels out x, and then we are left with the integral from e to 3 of 1 over u times du. Remember that the lower and upper limits are all values of x, so we need to find the values of u. So for u equals ln of x, when x is equal to 3, we have u to be equal to ln of 3, and that is equal to 1.0986. And then when x is equal to e, we have u to be equal to ln of e, and that is equal to 1. Therefore, we have the integral to be equal to, now from 1 to 1.0986 of 1 over u du. Now when you integrate 1 over u du, then we are going to get ln of the absolute value of u, and we have the lower limit to be 1, upper limit 1.0986. So this will be equal to, let's plug in the values of both the upper and the lower limits into this. So we are going to have ln of the absolute value of 1.0986 minus ln of the absolute value of 1. So ln of the absolute value of 1.0986 gives 0.0940 minus ln of 1 is 0. It means that we have our final answer to be 0.0940. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.